Hello, good afternoon, students. See, last lecture, what we had is dipole. Is it? Look at this dipole we are done with. Now, today, what we'll do, we'll continue from the dipole itself. We have already covered that construction working of half wave dipole. Let me zoom it. Let me delete whatever I had. Okay, construction working of half wave dipole. This part we are already done with. Then I hope this thing is known. What is it? It's a distribution, current distribution. Is it? The same thing I have explained with some other diagram. Is it? Now, what is that? Let me draw it again. If this is a dipole, look at this. Let me draw it here. Let me draw the dipole. Look at this. This is one pole, this is another pole, and here somewhere I am feeding that dipole. Look at this. Here somewhere I am feeding that dipole. The input source is connected here. Input power is fed somewhere here from that end. Now look at this. What is there? This is open terminal of a dipole. So what is the voltage at open terminal? Obviously voltage at the open terminal is maximum. Is it? Voltage at open terminal, it is maximum. So voltage at short circuit or closed terminal, it is minimum. This thing is known. And what about current? Current, obviously it is exact opposite to that. It means at open end current is minimum, whereas at short circuit current is maximum. This is applicable to the current and this is applicable to the voltage. So if I want to draw the voltage and current distribution for a dipole, then look at this. The current distribution can be, or let me draw the voltage distribution first. This is voltage. At open end it is maximum. So it is maximum positive. Is it? And it will go to zero level at short circuit. If feed is exactly here, it means this is what my short circuit. Is it? And again it will go to the maximum. Look at this. It will go to the maximum, but in reverse direction. So this is negative and this is positive. This is actual voltage distribution on a dipole. This is a voltage distribution. Okay. Now the current distribution is, now what is current? At open end current is minimum and at short circuit current is maximum. It means here it is at the center it is short circuit. So at short circuit it is maximum. So if I want to draw, then I can draw a current distribution something like this. Good. And let me connect those lines here something like this, and this is what my current distribution and this is what my voltage distribution. The current and voltage distribution on a dipole. So here look at this. This is what current distribution of a dipole is shown. Is it? If I want to show voltage distribution here, then how can I show voltage distribution? Voltage distribution can be shown like this, or I will draw it by this end. This is what voltage distribution. Look at this. If I want to draw a solid line, then this is a solid line showing voltage distribution. So this is how current and voltage will get distributed on your dipole. Is it? The thing is clear now? See, as I am writing everything on screen, so obviously when I scroll down you will get things as it is. So I need to delete this. Is it? So let me delete this again. So this thing already we are done with. And now radiation pattern. See, radiation pattern also we had a discussion about. So what kind of discussion we had in a radiation pattern. Look at this. What is this? It's a 8 kind of shape. Is it? Let me write here. Okay, sorry. Every time I have to select the pen size. Look at the radiation pattern. Radiation pattern will be like this. Is it? It is a complete 8 shape. Look at this. An 8 shape is there. And this is called side view. There is a technical name for that side view. And this is what top view. I told you that if you are thinking about radiation pattern of a dipole, then you need to think about apple, a small compressed apple, or the apple which has very small height. Is it? Or as our Thorat sir explained, that you need to think about medu vada. Is it? An exact shape. And look at it. What is the technical name for that? For that means side view and top view. This has a technical term of azimuth or H and V. Is it? Now, so let me delete everything again. A radiation pattern, which is a pure side view, and it is a top view. It means you imagine there is an apple, a compressed apple, and what you are doing, you are cutting apple. For example, is there any round shape thing? Okay, you assume that if this is the apple, assume this is the apple, and you are cutting this apple from the vertical knife. Is it? So why they call it is a side view? View is something you are looking from this side. Is it? If you are looking from this side, then obviously the side from where you are looking perpendicular to that should be the cut. Is it? So if you are looking from this side, then perpendicular to that will be the cut. So apple is cut with the vertical slot, and if you look from this side to the apple, then you will get the 8 shape as it is. Look at this. This shape you will get. Is it? Now it is a top view, or it is a vertical view. This is a horizontal plane, or some people call it as a H plane, and this is V plane, that is horizontal and vertical plane. Now look at this vertical plane, or what I can say, top view. Top view, just you need to look from the top. Imagine there is a medu vada put on the table and you are looking it from upside. So if the view is from upside, it means we have to cut it perpendicular to it. Is it? So if you are looking from the upper side, we have to cut that apple or the medu vada, whatever it is, from the horizontal side. Is it? So cut the knife like this in the horizontal plane and look it from the top. What you will get? You will get a clear circle. Is it? This is what radiation pattern you will get. Look at this, a clear circle. So what is that clear circle? It is omnidirectional radiation pattern. Omnidirectional radiation pattern. It is an 8 shape, and this is pure circle, or what I can say is omnidirectional radiation pattern of a diode. Is it? In last lecture we had a discussion about how diode will bloom the radiation into the air. Is it? And here we are in 2D radiation pattern. In last lecture we have seen 3D radiation pattern also. Now let's turn towards the advantages and disadvantages of a radiation, of a dipole. But before that, look at the thing what they have written. The radius, look at this, the radius of a dipole does not affect its input impedance in half wave dipole. Half wave means what? The length is equals to exact lambda by 2. This is what half wave dipole. Now imagine this. I have a wire. This is single wire, and this is another wire. Obviously it's a dipole, it's a wired antenna, so I have 2 wires, and now they are having a comment on the thickness. Is it? that is radius of a dipole does not affect the input impedance. No matter what is the radius of this wire, it does not affect the input impedance of the dipole. Now why? Because the length of the dipole is half wave and it is the first resonant length. I told you in the last lecture that when Marconi started inventing antenna, what they concluded? He concluded that a single wire can radiate. Is it? Then after some improvements, Hertz says that even two wire can join together, they also can radiate. After Hertz itself made some corrections and said it's the two wire combination, that is this dipole that I am talking about, it will radiate, but it will radiate efficiently if its length is lambda by 2, and then he give name as dipole. Is it? Dipole itself is a Hertz antenna, but Hertz antenna itself cannot be a dipole. Dipole is efficient radiator than Hertz antenna. Is it? So that's why even if there is a change in this radius or the dimension of a wire, there should not be any change in the impedance. Is it? Now what are the advantages of using this dipole in real applications? Look at the first advantage. Input impedance is not sensitive. Just now I said that even if there is a change in the thickness of the wire, then also input impedance will remain same. Is it? It has good stability. That is, they have written not sensitive. Is it? Now then it matches well with transmission line impedance. The impedance matching becomes very easy. The impedance of a dipole, that impedance will always match with the transmission line, and the matching becomes very easy. Effective matching is there. Is it? Generally transmission line or connectors we design for 50 ohm or 75 ohm. Is it? Russian and European standards are 50 and 75. We use Russian, that is 50. All the connectors, all the transmission line that we use generally are of 50 ohm impedance, and to that 50 ohm impedance or 75 ohm impedance matching to the dipole becomes very easy. Now third, it has reasonable length. Is it? So it means कि dipole का length इतना ज़्यादा नहीं होता कि it is practically impossible. No, it's not like that. Any practical length is possible for any frequency. Is it? I told you that every antenna is designed for a particular frequency. For example, there will be separate dipole for 1 gigahertz. There will be separate dipole for 2 gigahertz frequency. Obviously, the 1 gigahertz means its lambda will be different. Lambda is different means lambda by 2, that is length will be different. The dimensions of a dipole will be different. For 2 gigahertz, lambda will be different. Obviously, lambda by 2, that is length will be different. So for every frequency, dipole dimensions will get changed. So for every frequency, dipole is different. Is it not? So basically, antennas are designed, or resonant antennas are designed for a particular frequency. That's what the conclusion. Is that? Now, last but not the least, what they are saying, length of the antenna matches with size and directivity. Now what they want to say, length of the antenna means actually length, this I am talking about, this complete length matches with size and directivity. Is it? मतलब ऐसा नहीं होता कि this diameter, or what I can say, छोटा, there is a small frequency and impossible or impractical dimensions. No, it's not like that. Is it? Or the directivity. Is it? So the antenna जो है, the dipole, it always has a good matching with its size. मतलब ये size के अच्छे proportion में ही होता है. Is it? There is no impractical size as such or impractical directivity as such. So that's why dipole is always suitable. So those are some advantages of using dipole. Now let's observe some disadvantages also for a dipole. Is it? So what are the disadvantages? Let me show you the disadvantages. And the biggest disadvantage is here, no much effective due to single element. So what is the dipole? Dipole is basically a small single element. Is it? Single element रहता है ना. Look at this. Wires two है, but element तो single ही है. single element with length L is equals to lambda by 2. There is a single element, is it? If I fold it, then it becomes dual element, is it? For the time being हमें fold नहीं कर रहा है, we need to think only about a single element of, that is what dipole is. बेचारा अकेला रहता है, so obviously it is not much effective, is it? So now why it is written there? Because in next session you will have a study of folded dipole also. Folded dipole, there will not be single element, there are two elements, one element is folded and connected to the main element, is it? So that's why they have written, because of a single element it is not much effective. Now the second disadvantage is it can work better only with combination. मतलब अगर डाइपोल को आप किसी और एंटीना के साथ यूज करो देन इट विल वर्क वेरी गुड, इज इट? बेटर परफॉर्मेंस देता है वो, अकेला इतना परफॉर्मेंस नहीं देता. फॉर एग्जांपल इफ आई यूज a single dipole with folded dipole, you will get improvement in the performance, improvement in the directivity, improvement in the gain also. Right? But I use it single, obviously it will not work that much better. Is it? So that's why they have written that it will work better with the combination. Is it? So those are only two disadvantages. Otherwise, dipole is a very good antenna, the basic antenna. Now, what are the applications? See, if I want to write, then I can write so many applications for the dipole, but few are listed here. The first application is radio receivers. You have studied that radio receivers in analog communication. Is it? You will study actually. It is there in second semester. No, you people belongs to third year. So you have already studied analog communication. Yeah, you have already studied analog communication. So radio receivers are known. So generally or normally in all radio receivers the dipole is used, because dipole is a good element to receive that small frequencies, is it? So that's why radio receivers are generally preferred this dipole. Dipole को भी prefer करते वो लोग. Then used in television receivers. Right, I told you that dipole can work better. This is the best advantage. Disadvantage. It can work better only with combination. Is it? So in television receiver, dipole is used with combination of folded dipole and number of dipoles. Is it? Actually आपने अगर old वाला television set देखा होगा that uses Yagi Uda antenna, then what that Yagi Uda antenna is, there is a small reflector, that is dipole. One dipole is there, then main element, that is simple folded dipole, then again there is a dipole, then again there is a dipole. Those are number of elements which are connected in series, is it? So that's why टेलीविजन रिसीवर्स में क्या होता है, बेसिकली टेलीविजन रिसीवर के एंटीनाज में डाइपोल का कॉम्बिनेशन होता है. एक्चुअली इट इज एन array of antenna. So intentionally I am not using the word array because again there will be confusion that whether I need to apply source voltage or I need to take voltage from every element. There can be a question like that. Is it? So that's why intentionally I have not used the word array. I am using Yagi Uda antenna. I'll tell you afterwards how can I treat that Yagi Uda antenna as an array. Yes, I'll. But for the time being, you understand that it is used in television receivers. Then when employed with others, मतलब अगर हम किसी और के साथ यूज करते हैं, किसी और एलिमेंट के साथ, that's what I'm talking about. Used for a wide variety of application. Obviously, अगर मैं डाइपोल को कॉम्बिनेशन में यूज करूँ, सिंपल डाइपोल के साथ यूज करूँ, फोल्डेड डाइपोल के साथ यूज करूँ, so I can have plenty of its applications. I can list the applications number of. That's right. There can be so many combinations of a simple dipole. Is it? So this is all about simple dipole actually. Now before starting with this, which one this? Half wave folded dipole. Now see, we are not going to start with folded dipole immediately. Before that, I will tell you how I can design the practical simple dipole. Is it? See, the design is so simple. Okay, let me draw it first and then, okay, if I want to design dipole for 1 gigahertz. Now look at this, frequency is equals to 1 gigahertz. Now f is equals to 1 gigahertz, then what will be the lambda, value of lambda? The lambda is what, generally it is c by f. What is c? C means 3 into 10 raised to 8 divided by, what is f? F means 1 gigahertz, so 1 into 10 raised to 9, is it? Then what will be the lambda then? Do it. 0.3 meters. 0.3 meters, yes it is. This minus 9 will go, minus 9 plus it minus 1, so obviously it is 0.3. Let me change the color of the pen, whether it is possible. It's not happening. Okay, why it is not happening? Let me check for some time. So where we are here. So lambda is equals to 0.3 meter. So as if lambda is equals to 0.3 meter, the length of the dipole will be then L is equals to lambda by 2. It means it is 0.3 divided by 2 meter. Is it? That is 0.15 of meter. This is what length. If you want to design a dipole, then your design will be like this. This is actual dipole, and the length of the dipole, this you will keep it as an 0.15 meters for 1 gigahertz. This is what. Now for 2 gigahertz, obviously your dimensions will be different. From frequency, calculate lambda divided by 2, and that's what design of dipole. See, things are so simple. Now as if we have seen a dipole, its construction, working, actual operation, how dipole blooms the electromagnetic waves into air, that also we have seen. And then we have seen its radiation pattern even in 2D and 3D also. After that, what we have seen, a design of a dipole, its advantages, disadvantages, applications. So here we have covered almost everything about dipole, is it? And next part that we are going to start with is half wave folded dipole. Alright. Now after folded dipole, let me tell you what we have in future lectures. Is it? We are going to turn towards the radiation pattern of even dipole, folded dipole, full wave is also there in our list, short dipole is also there in our list, and then lastly we have long wire antenna, that already we are done with. And then V antennas. So V antennas we are not going to discuss because this is very common actually. So here we are concluding our session with dipole study. In next lecture we will start with folded dipole and then short dipole and everything. Okay, thank you.